Hello students, we have already learned that based on subshell electronic configuration, elements are classified into 4 blocks S, P, D and F in modern periodic table. The block to which the element belongs will be the same as the subshell to which the last electron is added to. Today in this section we will be learning about S block elements. S block elements are represented at the extreme left of the modern periodic table. What are S block elements? The S block elements of periodic table are those in which the last electron enters the outermost S orbital. The group number of the element can be found on the basis of subshell electronic configuration. Let's consider few examples. A table consisting of 4 elements along with electronic configuration is given. So, if we consider lithium, the electronic configuration 1s2, 2s1, that is, one electron is present in the last subshell. So, this element will be placed in first group. For sodium, the electronic configuration is 1s2, 2s2, 2p6, 3s1. That is, one electron is present in the last subshell. So, this element will also be placed in the first group of the periodic table. For magnesium, the electronic configuration is 1s2, 2s2, 2p6, 3s2. That is, 2 electrons are present in the last subshell. So, this element will be placed in the second group of the periodic table. So, for calcium, the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So, here 2 electrons are present in the last subshell and this element will be present in the second group of the modern periodic table. What is the relation between the number of electrons present in the last S subshell and their group number? The number of electrons present in the last S subshell and their group number is same. If we consider the example of lithium, the electronic configuration of lithium is 1s2, 2s1. That is, one electron is present in the last subshell and this element is present in the first group of the periodic table. So, we can say that the S block elements, the number of electrons in the outermost S subshell will be the group number. Here you can see the elements of the first group. These first group elements are also called as alkali metals. They have one electron in their outermost subshell. They are monovalent and they show +1 oxidation state. These are the second group elements. They are also called as alkali earth metals. They have 2 electrons in their outermost subshell. They are divalent electrons and they show +2 oxidation state. Now, if we consider first group element as X, since first group element have one electron in their outermost subshell, they have a valency of 1 and their oxidation state is +1. The symbol of ion of first group element can be represented as X1+, and the chemical formula of the oxides formed from first group element can be represented as X2O. If we consider an example of lithium reacting with oxygen to form lithium oxide, that is 4Li reacting with O2 to give 2Li2O. So, for second group elements, it can be represented as Y. Their valency is 2 and their oxidation state is +2. And the symbol of ions formed by second group element is given as Y2 plus. The chemical formula of the oxides formed of these group element is YO. So if we consider an example of magnesium reacting with oxygen, so that is 2Mg reacting with O2 gives 2MgO. So from this table, it is clear that the S block elements show definite valency and oxidation state. If we consider few common characteristics of S block elements, they are less ionization energy. That is, the minimum amount of energy required to remove the most loosely bound electron is less. They are less electronegative. Electronegativity means less tendency to attract electrons. They show all metallic characteristics like ductility, malleability, sonority, thermal conductivity and all. The compounds formed from this group elements are mostly ionic in nature. They easily donate electron in a chemical reaction. The first group elements of S block have greater reactivity in their respective periods. The oxides and hydroxides formed by this group elements are basic in nature. Their reactivity increases as we go down the group. So, when S block elements react chemically, do they donate or receive electrons? We know that they donate electrons. Why do S block elements show positive oxidation state? In normal state, an atom has equal number of protons and electrons. When one electron is lost, there will be an excess of positive charge resulting in the formation of cation. That's all for today's section. Thank you.